Okay, let's be real. When you hear organic chemistry, you probably have flashbacks to terrifying textbooks, right? But what if I told you it's not about memorizing a bunch of random formulas? It's actually the story, the epic story of one single element that builds, well, everything around us, from us to the most mind-blowing technology. You ready to dive in?
I mean, look at this. It looks like something straight out of a sci-fi movie, doesn't it? What you're seeing are carbon nanotubes. This stuff is so ridiculously strong that people are seriously talking about building an elevator to space with it. But here's the kicker, the part that just blows my mind. They're made from the exact same stuff, the very same element, that you'll find in the simplest little microbe on our planet. All right, think about this for a second. You've got a cupcake, right? A delicious, sweet treat packed with all sorts of organic goodies. And then you have the plastic wrapper it came in. One is food, the other is, plastic. They seem like they're from totally different worlds. But here's the secret. If you zoom all the way down to the molecular level, they're practically family. They are fundamentally connected. So that's the big mystery we're trying to solve here. What in the world is the secret ingredient? What's the one thing that connects futuristic supermaterials, the food we eat, and the plastic we use every single day?
All right, let's get to it. We're about to uncover the chemistry of, well, everything.
So, the answer to our big question, it's almost shockingly simple. It's a single hero atom, carbon. Yep, that's it, just carbon. This one little element is the unsung hero of, well, basically everything. It's the master architect behind literally millions of different things in our universe.
Okay, so what does organic even mean in chemistry? The official definition is pretty straightforward. Organic compounds are just compounds that have carbon in them, usually bonded in a special way. You can think of it like this. Inorganic chemistry looks at the whole periodic table. Organic chemistry, it's like we're zooming in and doing a deep, deep dive into the incredible universe of just one element, carbon. So we've established that carbon is the star of the show. But why? I mean, what's so special about this atom? Well, that's what we're about to find out. Carbon is the ultimate building block for a reason. It all starts with this number, 4. This is carbon's first superpower. Every single carbon atom can form 4 strong bonds with other atoms. Think of it like a person with 4 arms who's amazing at holding hands. It can connect in 4 different directions at once. This makes it the ultimate networker of the atomic world, building these stable, complex webs that are the foundation for, well, everything. Okay, superpower number 2 has a fantastic name, catenation. And what it means is that carbon isn't just good at bonding with other elements, it's amazing at bonding with itself. It can link up one after another to form these incredibly long, stable chains and even rings. Now, a few other elements can kind of do this, but carbon is the undisputed champion. It's this ability that lets it create the backbone for millions upon millions of different molecules. And here's a fun little piece of trivia for you. The word catenation actually comes from the Latin word catena, which just means chain. How perfect is that? So carbon is literally the master chain builder of the universe. So being able to form 4 bonds and link up into chains and rings, that's already pretty incredible. But carbon has one more trick up its sleeve. And this is the one that really blows the doors wide open on what's possible. And that final trick is something called isomers. Isomers are basically compounds that have the exact same molecular formula, the same set of parts, but they're put together in a totally different way. The best way to think about it is with Legos. Imagine you have a box of bricks with an instruction manual to build a car. You could follow it and build the car, or you could take those exact same pieces and build a spaceship instead. Same parts, totally different results. That's what isomers are. And here is a classic real-world example. On the left, you've got ethanol. That's the alcohol in beer and wine. On the right, dimethyl ether, which is a gas they use in stuff like aerosol cans. Now get this. They both have the exact same formula, C2H6O. 2 carbons, 6 hydrogens, 1 oxygen. The exact same parts list. But one is something you might have with dinner, and the other is definitely not. Their properties couldn't be more different. So how is that possible? It's all about the arrangement. In ethanol, the atoms are connected like this. You've got the 2 carbons in a row, and the oxygen is tacked on to the end. That little OH bit on the end is super important and gives ethanol its unique properties. But now look at dimethyl ether. See the difference? The oxygen atom isn't at the end anymore. It's wedged right in the middle. between the two carbons. It's such a small change in the blueprint, but it creates a completely different molecule with totally different behaviors. That right there is the magic of isomers. Okay, so carbon and hydrogen are the dynamic duo, but things get really wild when you start inviting other elements to the party. Just look at this contrast. On one side, you have a simple fatty acid. It's basically just a long chain of carbons and hydrogens. It's great fuel, a good source of energy. But now look at the other side. This is luciferin. It's still got that carbon backbone, but now we've added oxygen, nitrogen, and sulfur into the mix. And what does this new, more complex molecule do? It's what lets a firefly light up the night sky. It's incredible! By just adding a few new ingredients, nature goes from a simple fuel source to a living, breathing lantern.
So let's bring it all home, from atoms to us. So let's just do a quick recap of carbon's superpowers. Number 1, it can form 4 strong bonds. Number 2, catenation. It creates amazing chains and rings by bonding with itself. And number 3, isomers. It can build completely different structures using the exact same set of atoms.
When you put all that together, you realize what carbon really is. It's nature's ultimate Lego brick. It's a simple, powerful, and incredibly versatile piece that, just by following a few simple rules, can be used to build almost infinite complexity. We're talking everything from a simple molecule all the way up to the blueprint of life itself, DNA. So that leaves us with a really exciting question. We have this ultimate building block, carbon, and we understand its superpowers. So what are we going to build next? What new medicines, new materials, or new technologies are just waiting to be created? With carbon, the possibilities are pretty much endless.